Thank you. So as was mentioned, the topic today is integration testing, and I think this is actually a very exciting time given the advances in integration testing on the Java platform makes it easier than ever before, and the things that you can actually do, that you can do today are amazing compared to where we were just 5, 6, 7 years ago. So an assertion I'm going to make is that no other platform has better integration testing for server-side applications than Java. And I think by the end of this presentation, you'll see that that's the case. It truly is amazing what you're able to test. You can now simulate networking issues. You can test for latency. You can simulate all of that stuff and test how your application is going to behave under those circumstances. You no longer have to foist that type of testing upon your users. There's no longer an excuse for doing that. So no longer can you say, well, geez, the network is too slow. Now you can actually test for that in your integration testing. So testing server-side applications, what do we want to test? We want to test the obvious things: persistence code, web services, and or web sockets.
To this over here, because this one is not part of the video.
Oh, okay.
If you go over there, this one.
Talk. Move over here. I'm not sure where. Oh, okay. Okay, so testing server-side applications. So what do we want to test? The obvious things: persistence code, web services, make sure that they actually work. Don't say that for the JavaScript developers. Exception handling. What happens when, is your exception handling correct? Did you have some developer put in the try-catch with e.print stack trace to a log file that goes out and rotates, before you're actually able to gather it from production? Process crashes. What happens when you kill an application container? What happens when you get a Java out-of-memory exception in your ActiveMQ server, taking everything down with it? Load tests. How does your application, can you load balance your application? How does it behave? Because obviously just because it works on one developer's machine doesn't mean that when you scale it across multiple machines, the application will still work. Failures, exceptions, bad data. The user is always going to, input something unexpected for apps written over in the United States in umlaut or some other character that's not expected with an encoding set to ASCII. Performance behaviors, JavaScript interrupt, and also concurrent access, right? So, that's usually, something rolls out to QA and then you find out that it doesn't exactly behave correctly under concurrent user access. So these are the challenges with server-side testing. And to a lesser degree with desktop applications. But this is, as we'll see as we go through the presentation, testing all of these things is now possible and easy. So testing applications that run server-side is challenging because you've got the container control, starting and stopping the application deployment, resource configuration. It's hard to do in the past, right? You couldn't actually do this from your IDE. You couldn't kick off a test that would run over in Tomcat or in Pyra without, kicking off and executing a bunch of scripts, etc., right? So the challenge is that it has to be easy, it has to be fast. Infrastructure with the testing, the availability of databases, queuing systems, also artifact generation, being able to generate the output and not have it take a long time, because some applications are fairly large, and what you actually need to test is only a small part of it that you need to actually build up. Also tied into artifact generation, being able to insert mock objects, use something like Mockito to mock out key parts of the system to affect behavior and how the application behaves, etc. And the question at the bottom is this possible or is this reaching too far? And the answer is that this is definitely possible, and we'll see many examples of this as I go through the presentation. Why is it hard? Integration testing is where you put everything where you put the entire application together and see how it behaves. And for the reasons that we just saw, starting up application servers, launching all that stuff is hard traditionally in the past. I still see projects that have like miles and miles worth of scripts that are trying to start up containers, shut down containers, deploy stuff. And I think sometimes that more time is spent trying to debug those things than actually debugging and testing the actual application. So that's been definitely a problem in the past. So the solution to all of this is Arquillian. And now Arquillian integrates nicely with Docker and also Kubernetes, which kind of gives you this nice nirvana of testing, where anything is possible. And it's anything is possible and is extremely easy. Using Arquillian and this environment, you can test all of these containers. You can test not only your traditional full-fledged Java EE, WebLogic, WebSphere containers, you can also test Tomcat, you can test Spring applications, or you could test just standalone Java applications that you're deploying. So if you have something that doesn't even run in a container now, you can easily test that using Arquillian as well. Really, it's a wealth of choices as you go through, and trying to figure out how you're going to structure your application, given that it doesn't really lock you into anything, can be the challenge. Leveraging Arquillian and Docker. With that, you end up with no spaghetti script. You can create custom test environments. You can actually test against multiple containers. So if you have to support multiple containers, say, WebLogic and Tomcat, or, TomEE and Pyro or something like that, you can actually set up and do regression against both of those. You have seamless build integration, so the testing is not being done through the build system. So the build system you're not tied to a build system, for instance. You're not building up a gigantic system in order to try to do this. With this, you get continuous integration testing that's easy. You're not locked into a unit testing framework. You can use TestNG or JUnit, either one of them. With the IDE integration, there is no plugins that are needed, so you don't need to use Eclipse in order to run these Arquillian tests, right? All the tests, including tests that launch your container, can run out of your existing IDE, whether that's NetBeans, IntelliJ, or Eclipse, or some other IDE, or Emacs if you're using that. Build system support supports both Maven and Gradle. Gradle being a little bit harder, given some of the differences, given that most of the example code that's floating around out there is using Maven. And it supports Java EE 6, 7, 8, the web profile, and also testing of OSGI-based applications. So Arquillian. So if you're not familiar with Arquillian, Arquillian's actually been around for a number of years right now, so this is not a new project. This has been around for, I want to say almost 10 years at this point. It continues to grow and continue to evolve, and I'm always shocked at the number of people that aren't using it yet. So it's a JBoss project. It supports JUnit and TestNG. It deploys and manages the containers, as I've mentioned already. The framework is composed of three parts. Test runners, right? So you're going to write your tests using regular JUnit. Containers, those being WebLogic, Tomcat, etc. And then finally test enrichers. It's actually going to enrich your application and allow you to inject code into it. It leverages something called shrink wrap, which is another JBoss project, which will build up the images that you're going to execute, right? Because very often your build system is going to produce the final WAR file that you're going to deploy into production, or your file or jar file, whatever you're deploying in production. But when you're running tests, sometimes you might have code that runs on startup, which for the purposes of your test you don't want to execute. You might want to replace certain classes with mock instances or dummy instances that are going to behave differently. And if you had to write the code and then modify your build system in order to support that for each of the different tests and repackage it up every time, that would be very labor intensive and complicated. And that's one of the things that Arquillian with shrink wrap eliminates the need for. As I mentioned, it supports Maven. It works perfectly well with Maven and Gradle for the dependency management. Not Ant out of the box, so if you have an ancient project that is still using Ant, you'd have to get it over to something modern, or reverse engineer all the dependencies that are being used by Maven and Gradle, which would be quite an undertaking. One of the nice things with Arquillian, so there's the top level Arquillian core project, and then you've got many extensions to it, and there seems to be a new extension on a regular basis. It's sometimes hard to keep up with what's going on in this ecosystem. So most of these ones we're actually going to look at today. I'm not going to actually look at the performance one, which allows you to annotate your test for performance, so you can tell if your performance, somebody checks in some code and it affects the performance of your application, so you can actually test for things like that. I'm going to cover Arquillian Kube, which allows you to manage and run your application and test using Docker containers. Drone, which is testing of web-based applications and leverages and wraps the Selenium WebDriver for you. Graphene, which is a set of extensions for Selenium, basically rests on top of drone, which improves the ability of you to write reusable tests and integrates with drone. Warp, which we'll see briefly, which enables server-side tests to be executed on an HTTP invocation. This is gray box text testing, right? So you are executing from outside, you execute some type of web action, for example, for a web application, and then you check to see what the state is on the server, right? So black box testing, you're executing stuff, making sure it behaves correctly, but you're not actually looking inside of it. With gray box testing and warp, you execute a test and then you check to see, what data model was created on the server. Was it what was expected? Not just did it return the correct thing to the user. What did it insert to the database? The persistence plugin, which we'll see briefly, allows you to load data into the database for your tests and also compare the database. Say the database should be in the state at the end of the test. And you don't have to write code that's going to interrogate the database and figure out what the final state is for that. They provide basically a file that you would fill out saying this is what should be in the database after the tests run. Clears out the databases before they run, so this reduces the amount of code that you actually have to write. Adding Arquillian to a project is pretty trivial. The best practice, of course, is to use, if you're writing with Maven, to put the different versions up at the top that you're going to pull in, which are those properties right there. And then you pull in the bill of materials for the different projects that you're going to use. In this case right here, I'm using Arquillian Core, which is the top one, Arquillian Cube, and then using the drone down below. So I'm pulling in those 3 bills of materials. Now there is some order dependency between the bill of materials, so they usually tell you to put, like, I think it's Arquillian Core up at the top if I remember right. And then down in your dependency sections, you specify, in this case, I'm depending upon JUnit for container. There is container versus standalone. I can write tests that are going to be running against a running container, or I can write tests that are not actually going to deploy code. They're just going to execute against a container, right? So, you might, depending upon, whether you're taking an existing project and adapting it, you'll pick one or the other. And then the other dependency up there is the Arquillian Cube, which allows me to control Docker containers. With container management, there's actually several different interaction styles. There's remote, where the container resides in a separate JVM. So say you have a complicated application server that requires a lot of custom setup and you want to test your code against that. You're going to deploy your application to that. So in this mode here, you're going to, remote mode, you're going to deploy your application to that remote container and execute it, and run your tests against it. Managed, the container is remote, but at the start and stop is controlled by Arquillian. So it's, you've downloaded it, you've set it up on your laptop, and you tell Arquillian, okay, the container is located over in this directory, you can start and stop it. And finally, embedded, the runs in the same JVM as the test. So this is actually this is where people usually start off with. You run the tests, it fires up an embedded Pyre, an embedded WebLogic or WebSphere, executes your tests, and then shuts down the container in the end, right? There's no separate installations. You didn't have to set anything up. You just said, I'm using, Tomcat, run it in embedded mode, and you don't have to set anything up. You don't have to download anything. In terms of container capabilities, it has support for JBoss, Wildfly, Pyre, etc., serval containers such as Tomcat and Jetty. You can do standalone tests against OpenEJB, also Weld, so if you're testing like a CDI layer, OSGI tests as well. Now some of the different containers, in this case right here, we can see that GlassFish Pyre supports embedded, managed, and remote. WebSphere Liberty only supports, WebLogic only supports managed and remote, which means that you can't run your tests within the same JVM. It can't run them in embedded mode. Run modes now. So you're firing up your container application. You're running your test. Where does the test actually run? So you can run the tests within the container and thereby inspect the state of the application as the tests execute and inject resources directly into your application. So you can get a hold of a CDI bean and do something to it, and then check to see if the changes check to see how the changes affected the system. So that's where you're running your tests actually within the container, right? You can also run your tests outside of the container. So this is where you're going to be testing web services, where you make a web service call and you see how the system responds if you're testing JavaScript code. Tests that are run outside of the container are run as client, right? So the first one within the container, your JUnit actually runs within the container itself, which means that you can access everything inside the container. You can access DAOs, you can inject singleton beans into your test, you can check and see what they're actually doing. In test enrichment, if you're running inside the container, you can inject resources, inject your CDI beans, the persistence context. So for example, you can have your entity manager injected. You could check the state of the database. If you're not using the database thing, you could check to see, execute some code against the database to see what the final state was, etc. Also, you get a hold of request and conversation, access interceptors and decorators. So all of the stuff that you're used to working with inside the container, you also have access to it in your tests. So as I mentioned, this is the Arquillian bomb pulling it in. Now to actually test for a given container, so we're going to include the Arquillian JUnit for the container, JUnit 4. And then finally, if we're doing remote, we're going to include the dependency for remote. So Arquillian is going to look at the class path and say, what is on the class path? Is it a remote? Was a remote dependency pulled in? Was an embedded dependency pulled in, etc. In this case right here, I've specified a remote, which means that the container Pyra in this case is running on, Pyra GlassFish is running on a remote machine. I could also have included, if I wanted to test an embedded one, I would have pulled in the embedded dependency, and you would set up different profiles for running different sets of tests, either embedded or remote, etc. Okay, so we've been talking high level, so let's actually look at some code and kind of, make it more concrete. So this is a JUnit, which is actually executing code within the container. So at the top, this is a standard JUnit we're using to run with, and we're saying we're going to run with the Arquillian test runner. We inject a CDI bean. So this is a bean that the application usually uses that I want to test. So I say inject this bean into my test. And then I have the test down below where I execute and check to see, what if the current meeting is set, etc. Whatever I'm testing on that bean. I could be injecting a stateless session bean. I could be injecting a Spring bean, and then finally the deployment down below. This actually is the first thing that gets executed. So this programmatically builds up what is in the WAR file that it's going to deploy to the container. Creates basically a virtual file system containing the application. So using this, I can specify which Java packages for my application do I want to test with. I can include from my test class path, I can include mock objects that behave differently, right? I could have a DAO layer that's going to throw SQL exceptions, for example. Every second call it's going to throw a SQL exception, and I can test to see how that's going to affect the UI of the application. Does it bubble up correctly? Does the transaction roll back? Does the message-driven bean roll back? Does the message get redelivered? I can test all of those things. I can mock out layers and see. That's where I said before. You can find out how is whether your exception handling is correct. How does the system behave when something goes wrong? Okay. This is an example of a web service test. So the important thing to note right here, once again, I'm doing run with Arquillian class. I've annotated the test method, test concurrent meeting service, and I'm saying run as a client, which means that this test is going to execute outside of the container. So there's going to be two JVMs for this test. There's going to be the JVM that's going to fire up the application server, because I know, which is not in the code on this slide, but I'm actually running it embedded mode. Right, so it's going to fire up a JVM for the container, and then in the JUnit JVM is going to execute and call the web service, and then I'm going to check to see, what the results were. I could also run that in the container where I, call localhost, and then I could inspect the state of the server to see whether the server state was correctly mutated or not. And the project layout, notice that there's no app container or anything specific. It's just a generic application. So you have a standard, Maven Gradle application. There's nothing, there's no I didn't add in any dependencies into it for, the containers. There's no zip files with WebLogic or Tomcat or anything like that. It's just a standard application that you can deploy. In addition, I mentioned the ability to do persistence. The persistence extension for Arquillian. So you include this in your dependencies for Maven, and then you can annotate On your methods, I want to use this data set, right, which means that it was going to load that data set before running the test, right? You can have it clear out the database, so you start with a known state, specify, and there's several different formats, so you can specify it in JSON, YAML, SQL, whatever you want. There's a tons of control with it, so in this case right here, the second test, I'm saying apply this script before I run the test, and then it should match this data set after it's done. So I can check to make sure, did my DAOs correctly insert all of the fields into the database? You know, was the state of the database correctly, you know, mutated as a result of the test? Right. So I don't have to write a test, insert some data into the database, and then write more code to try to say, okay, was it inserted correctly? You know, make sure duplicate records weren't inserted. It's going to check to make sure that that data was inserted correctly. Right. So not also, you know, very often you run into trouble where there's a bug in the test, right? And it turns out that, you know, that the test didn't include everything, or somebody added a new field that wasn't checked. Tying this all together, as I mentioned, shrink wrap, which is the API for programmatically building artifacts. It eliminates the system script spaghetti. So as you notice in the examples that we've seen before, I have not made changes to the build system in order to do this, other than pulling in the dependencies. For Arquillian, I've not had to, you know, build up something where I construct a war file as a part of the test. This is before you actually produce the final war file. It supports different outputs, so you can generate a jar, a war, an ear, I think an RAR, etc. So you can test all of these, produce these outputs. With shrink wrap is the main entry point. It's a very simple API, and you specify, you know, what you're creating. You're creating a web archive, and then you get that archive object back, and you populate it with the artifacts that you want to go into it, right? So this allows you to control specifically what your test is actually, the classes that are going to make up your thing. You're not deploying your entire application, which has startup logic that's going to scan stuff, join clusters, whatever else. You can limit, you can test specific parts of your application. You don't have to deploy the entire thing. It also allows you to replace key parts of it. So as I mentioned, you can replace the DAO layer with some dummy DAOs that are going to throw exceptions. You can say, well, I'm going to include, you know, this set of DAOs instead. And it's got, you know, you can add individual classes, you can add directories, resources, and it also has something called resolvers, shrink wrap resolvers, which allow you to pull in dependencies from Maven and Gradle. So you want to package up into your WAR file to then deploy to your remote container. You need to pull in your Hibernate dependencies, your Hazelcast dependencies, etc. It allows you to pull in, and that's the integration with the build system. So it allows you to check what your dependencies are, and then conditionally pull them in. This is a more complex example where I'm building up multiple packages, adding in resources, etc. You can even inline those, right? So I can, as a part of my tests, I have a test persistence XML, a separate one that I use for testing, right? Then the one that actually gets built up and deployed with shipped with the application. So I can pull in for each test. I could have a different database configuration for it. So it gives you a lot of control. I could do substitution and replacement on this. Here I'm just including files, but I could actually generate these files on the fly as well. In addition for debugging, sometimes, you know, you forget something and you want to see, you know, what actually ended up in it. You can actually take the output of this virtual file system and you can generate a zip file or something else that, you know, a tar file that you could then examine afterwards. You know, if you keep getting an error message that you're missing some type of dependency, some type of class at runtime, that's an easy way of debugging it. Configuration. So as I mentioned previously, the container is selected based upon the class path. So you add the container that you're going to be used for testing using Maven or Gradle, using profiles, of course. So if you're testing multiple application containers, different versions of the application, you'd use different profiles for that. The main configuration file for Arquillian is arquillian.xml. It goes at the root of the class path, typically in the test class path. And the file is optional. And it configures how to communicate and locate the container, the port the container is running on, the host the container is running on if it's remote, and also serves as the dumping ground for all of the configuration for the extensions that we'll see as I go through the presentation. So the main thing is, that's the only thing that you really need to know, is the Arquillian XML for configuring it. As I mentioned, the containers are picked off the class path. So in this case right here, I'm using Arquillian Pyra for embedded. If I'm doing managed or remote, I'd pick one of the other dependencies. And then this is an example Arquillian configuration file where I'm specifying that the test browser. We'll see this in a second. I'm using Phantom.js right here for doing that testing. The container down below, I'm configuring the container plugin for GlassFish, and I'm specifying what port it's going to be running on. It's going to be running on a non-standard port, so it doesn't clash with anything else on the machine. But this is the file where all of the extensions and Arquillian core get configured into. So let's look at an example scenario. An embedded test using GlassFish. Application uses JPA and JTA data sources, and the test database is developer specific. So this is the project right here. I've got a custom Arquillian XML, GlassFish resources, test persist resources, and those are on the test class path. And then I build up programmatically this virtual file system using shrink wrap for the test that I'm going to execute, and I pull in my test persistence XML, etc., for the purposes of the test. All right. So as you can see, I'm not using the ones that are going to go to production. I'm using the ones that I'm going to use for testing, which behave slightly different. Okay. In addition, I'm providing a GlassFish configuration file for the embedded test, specifying where the database is and how to talk to it. Okay. So that's a basic introduction to Arquillian and shrink wrap with testing. Now let's look a little bit more at full stack testing, where we want to test our application across multiple containers and also multiple browsers, right? So this is where things kind of get tricky. So the full stack testing challenge is that we want to compile Java code, our Java unit test, transpile our JavaScript code now because everybody's writing in TypeScript that then gets compiled down to JavaScript, and you run tests against that. You run your JavaScript unit test. You're going to run your container unit test after you assemble everything. Very often right now with applications, the UI is done with Angular, React, which you transpile and then build up, and then you package that into your WAR file if you're doing a WAR deployment. And then finally, at the end, your browser integration tests. So you've got multiple levels of testing. You're doing testing of your back end, you're doing testing of your front end, you're doing testing both together. And so having seen people don't reverse engineer and try to use one build tool, use Maven and Gradle to drive the overall build and testing, the JavaScript output would be pulled in using shrink wrap. So for unit tests that are being done over in JavaScript land, you use the npm tools, you use the JavaScript testing tools in order to do that, and you integrate it into your build that way. So this is just an example build pipeline where you have your Gradle build, which runs the Java unit tests, executes your npm installs, runs your npm scripts, and then finally does the full build at the end. And a little bit more complicated integration testing using Arquillian, where we want to use Arquillian with JUnit with Selenium to run the tests, to execute Jasmine tests that are going to run in the browser against our Java container. So using Arquillian, this is now all possible, right? So we can test our Jasmine scripts, we can run them in the browser against a server that we've stood up as a part of our tests, right? So you don't have to have some type of test server out there that you're running in order to test your JavaScript. As a part of your tests, you can bring up your application container with all of your web services that your JavaScript code is going to test. You can inspect their state as a part of the tests, and you can run them. You can test running the JavaScript tests in different web browsers to make sure they behave correctly. And then further taking the integration tests a little further, we can run integration tests, which deploys Java containers, generates the deployments using shrink wrap, etc. This is just an example of it going in. And then we've got the capability of doing many different types of testing scenarios. So we could have on our builds, we could have build server, it could be, testing using the JVM, Tomcat with Chrome, testing the back end. So it can miss and match for different tests. So we can use the embedded to just test the backend server side. We could use the container-based approach, or the managed or remote approach. So we've got many different ways of testing our application now. We're not, only testing it. We're not limited to testing it only one way. So how does a JUnit being run by Arquillian launch JavaScript tests that go against a server? And the answer to that is using these three technologies. Either you can, and they build off of each other: Arquillian Drone, Arquillian Graphene, and Arquillian Warp. So Arquillian Drone is the one that basically wraps Selenium. Graphene stands on top of that, and then Warp stands further on top of, I want to say, both of them. So Arquillian Drone manages the lifecycle of the web browser. It enables you in a single test to test your application using multiple web browsers. In addition, it also supports, with extensions, the ability to test mobile web browsers. I think it's Arquillian Droid. It's compatible with Selenium 2 and the Selenium grids for testing. Arquillian Graphene is a simple API for developing reusable tests. It's basically a higher level that sits on top of Drone. Forces development of AJAX tests. It has a waiting API, guards, etc. that make it easier to test kind of asynchronous tests. And comes with abstractions for page objects, page fragments, which allows you to easily compartmentalize your tests, especially if you are testing multiple pages multiple times. jQuery selectors as a location strategy for picking out stuff within the HTML. Warp, which we'll cover towards the end, is gray box testing. It supports only the HTTP protocol. It supports, it's more tied to a framework, so it supports the servlet API and also JSF2. And there are extensions for Spring and MVC REST as a part of it. The drone dependencies are fairly straightforward to pull in, the BOM file and then your dependencies. And this is a simple example of drone, right? So in this case right here, we have this Arquillian resource, so we're getting the context path to our application. We don't have to have that hard-coded everywhere where the application is being deployed. So we've got the context path, and then we've got the Selenium WebDriver, which has been injected using the drone annotation. And we can go ahead and request a page back and check to see what was returned. So this is, we're actually, depending upon which web browser is being launched, being used for the test, it's going to fire up Chrome, going to request that page, and we're now going to be able to introspect and see what actually came back. So in the case of the Arquillian configuration file, I can specify, for example, Safari. So I want to run with a Safari web browser. So the test is actually going to launch a Safari web browser and go to the URL that I request that it goes to. Now, one of the neat things with these tests, because they're often hard to debug and figure out what happened afterwards, it has the capability with additional Arquillian extensions for recording the web browser tests. So I can have it record a video that gets saved every time it runs the tests. I can also have it take a screenshot if that's too much effort. I can have it take a before and after screenshot. See what actually happens. Build up some documentation that the test actually ran and did what I expected. So it's kind of nice that afterwards you get, if you're using the video recorder, you get a video recording where you can see it typing into the different fields, clicking on enter, and all the rest of it. And then you specify in the extension, you configure how you want it to record or take snapshots of it executing your tests. Graphene takes us one level higher. So before we'd have to, if we're just using drone, we're now going to have to go mucking around in HTML to figure out, what came back and analyze it, retrieve back, specific HTML elements, etc. If we're using Graphene, we have our drone annotation, of course, from the drone, but we can now use these find by annotations and say, give me the username field, give me the password field, etc. And then in our tests, we can actually, so the first thing that we do up there with the WebDriver is request a specific login page. We can then type into the various fields, and then we can have it click and make sure that it actually transitions to the next page. So this is all very nice, right? So you can do this all in code. In addition, Graphene also supports the ability to do JavaScript testing. So in this case right here, we have a hello world.js. So in order to test this from our Graphene 2/drone test, we create an interface called hello world, and we map it with a JavaScript annotation window.hello world, where it's going to be located in that page. And then in our Java code, we can inject hello world using the JavaScript annotation, so it's going to inject basically a reference to it, and now we can call hello world.hello, which is ultimately in the web browser going to call hello on our JavaScript function that we put up above. So this gives you quite a bit of control and the ability to test things. And then finally, warp. These are the dependencies for warp. And warp gives you the ability to basically do inspections on the server side, do something on the browser, and then check to see what happened back on the server side. And I want to say that for each of these technologies, this presentation is actually a lot of material. I could have done a presentation on each one of these technologies that I'm covering here today. So this is kind of the survey overview of everything to assemble. And then, so in summary, okay, let me move ahead. So what we've seen so far, don't run integration tests during a regular build. Split out the integration tests. Use embedded and remote test environments, as we've seen with the build. And now let's look at how to integrate with Docker and also Kubernetes with this. So with Docker, so the main thing with Arquillian is this package called Arquillian Cube, which enables the management and execution of Docker containers, which allows you to execute your tests in Docker containers. So everything that we've seen thus far, we could also use Docker containers for doing it as well. So with Docker, with Arquillian, with the Arquillian Cube, Arquillian will actually read the Docker, will control the Docker container for us. So we can have it start up a Docker container, can use a compose file, specify that we want a database started up, we want this web browser to be running from this Docker container, and we can start up and execute the tests that way. So now we can do all kinds of really interesting tests where we define in our compose environment, or if we're working with Kubernetes, our application is composed of an active MQ queuing system. We're using the Java, Tommy container along with PostgreSQL. We can actually fire up an entire environment using Docker and then test against it. Okay, so pulling in Arquillian Cube is fairly simple. In this case, right here, I pull in Arquillian Cube, and I make sure, because I'm now not going to be running my tests embedded within the same JVM, I'm going to be using the remote container. I pull in the remote container. Now, there's several different ways of generating the Docker images that's used for these tests. You can either define it in line with the Docker Compose file format, or you can use like a Gradle Maven plugin to generate the images that you're going to use in their tests. So this is an example right here of building Docker images. There's several different libraries out there that you can use for building up Docker images if you're not using Docker Compose, or you have a more complicated build structure as a part of it. So Arquillian Cube, the Docker settings get configured in the Arquillian.xml. And you've got multiple settings that you can specify. You can specify where your Docker registry is, the username that you want to use, the password, the machine, the cert path, etc. This is actually very easy to get running off the ground. So this is an example Arquillian configuration file where I specify that the environment is being specified in my Docker Compose YAML, and this is the file right here. So previously, in the previous slide, I was including the Tomcat remote server. So in this case here, I'm specifying that I'm going to run my application in the Tomcat 7 container. I expose the RMI JMX port so that the plugin can correctly deploy the application to that container, right? And then set up the passwords, etc. for that. This is the same example as before, except I'm doing it with something called cube format. So you can either use YAML or you can use cube format, where you embed it directly in the Arquillian XML file. They have some extensions in this which gives you the ability to do some sleeping, waiting until the application deploys, and some additional checking afterwards. And so as you can see right here, I specify the username, the password, etc. And then this is the test right here. So this test, this is actually an Arquillian Cube test, and you'll notice that I get injected in the Arquillian resource. So behind the scenes, I've configured the fact that I want the application with the Arquillian XML with my dependencies. I've pulled in that I'm using Arquillian Cube, the remote container, and then what Arquillian will do for me is it's going to take my application and deploy it to the Tomcat that's running in the Docker container, right? And that Docker Compose file that you saw before, I could actually build that out. I could have my ActiveMQ, I could have my PostgreSQL database. I could build up this virtual environment with, virtual networking, etc., with, my complete application as a part of it. I don't have to depend upon a test database that's in some state around me. Okay? So that's the quick introduction to Arquillian Cube. It's very simple. You can get up and running with this in about 10 minutes. It works on just about all of the current machines that are out there right now. It's very easy to actually use. So now we move on to Arquillian Cube Q, which actually builds on top of Cube. So as you can see, we're like building up. So we can take the Graphene, the drone stuff that I went over before, we can tie that in with the Docker containers so that we can run, we can have web browsers in Docker containers, we can have our tests running in Docker containers. We can have this whole entire virtualized environment where we could simulate, etc. So if you're familiar with the Cube Q, it's actually based upon Q from Star Trek, the guy that liked to introduce chaos, and really turn things upside down. It leverages something called toxic proxy underneath the hood, and it builds on top of the Cube extension that we just looked at. And so what does Cube Q allow you to do? It allows you to do really nasty things like suddenly your web services have 10-second latency on them, right? Or, oops, the database has gone down, ActiveMQ has gone down, it's just suddenly died, etc. So it allows you to simulate things that are going to happen during production, right? Simulate what happens when the database suddenly, stops responding. Simulates what happens when the queuing system goes down. So you could actually use this to simulate, if you're running with ActiveMQ, you're doing high availability with load balancing on your queuing system, you could test your configuration to make sure what happens when one of the ActiveMQ instances go down. Does your configuration that you're providing with your application roll over to the other one, right? So this allows you to do really sophisticated testing that, traditionally has been done by the users at deployment time. So the types of chaos things that you can introduce, a network with, there's three types. There's network, container, and operating system. With network, you can test latency, taking down a service, making it no longer available, bandwidth problems, slow close, timeouts, and also slicer. And slicer is where you divvy up the packets and you slow them down, right? You split up a packet and you slow down the data as it goes across, right? Container allows you to suddenly stop containers, kill them, what happens if your database goes down or crashes. The operating system ones, you can configure it to, block specific ports using IP tables. How does your application behave when the CPU is at 90%, right? What's the behavior going to be like, right? Because applications, race conditions suddenly come into play. When performance, when the CPU is at 100%, things start really misbehaving. Timeouts kick in, messages roll back from JMS queuing systems because it says, well, I haven't heard from you for 10 minutes, so it must, let me try replaying that message to you again. What happens when, it fills the disk and your clients aren't running APM tools and you're sitting there trying to figure out why your application has crashed? What's the behavior of the application when the disk fills up, right? So it's going to simulate that. What happens when you kill a process, that networking is royally screwed up and routes are nulled. So for pulling in these Q dependencies, you've got, you pull in the network one, the chaos one, or the OS chaos one, depending upon if you're using all three, and then you simply inject the relevant objects for each one into your tests. And you can go about wreaking havoc by adding latency onto your connection to the database, for instance. What happens when the database connection is suddenly very slow, right? So now you can have a lot of fun with your tests. Now you can do things in testing that traditionally, were very hard to do. You'd set up a one-time environment and test what happens if the database is underpowered or the connections are slow, right? I've seen people do those tests as one-off. Now this can be a part of your continuous integration testing. Yes?
What defines the PostgreSQL? I assume the second to the fourth and the first to the
Yeah, so the PostgreSQL, that's referring to the Docker containers. So that's saying this Docker container, and you're specifying that on this port you want it to add in 1,000 milliseconds, and it's going to execute this stuff inside of it. This is actually a contrived example. Somewhat contrived example for the thing. So now all of this stuff is all wonderful, and this also takes into play with Kubernetes. So the challenges are, where's the failure when something goes wrong? Code structure and complexity, cross-platform testing, different Docker environments. So if you're running on a Linux environment, you obviously won't have access to the Edge web browser, for instance, so it doesn't get rid of problems like that. There are very few examples of using Arquillian with Gradle, and it was kind of hard in the past before Gradle added the support for bombs, so it's gotten much easier with the advent of that. So, 5 minutes. So client and server-side testing, both of them can be easily tested right now, and you can really do some very sophisticated things with your testing. There are some resources. There are 2 books. There's actually one that I just discovered recently, in addition to the one that's up here, which I'll add to the slides afterwards. So there's 2 different books that go over Arquillian testing. Different takes on it. The Arquillian guides are very good. The one thing that I will say that working with Arquillian that can be very frustrating is that much of the documentation, if you paste it in from the website directly into your IDE, it won't run. And so that has caused me, a lot of frustration because some of the documentation refers to older versions which you wouldn't want to necessarily run with. So it's not necessarily uniform across the board. So I've spent quite a bit of time pulling my hair out trying to figure out why this example up on their website doesn't work, right? And so generally for getting around those problems, a lot of the examples that they have on the Arquillian documentation, if you check out the relevant Git projects, what they've done is they've actually pulled the samples from their unit tests. So you can actually go look at the full-fledged unit tests that they've written and figure out, and run it and figure out what is missing or what was pasted in incorrectly to the website in order to get it to work. One thing, I went early today, which I have not actually finished pushing the code there, but I've created a repo, and what I've done is I've been trying to create samples for all of these different things that actually work, right? So out of the box, you have a sample drone application, a sample using drone that actually works, a sample one actually using the Chaos plugin with the database with 2 containers, a Pyro container and a PostgreSQL container, to test to see how it works. So basically serve as better examples, because a lot of the examples that they have up there are kind of contrived, and when you actually try to do something real with it, it gets a little, the first time, as you're trying to figure out the Docker stuff, the Arquillian stuff, and then your configuration for your application container, it can be very frustrating initially. So with that, I think I've got 1 minute left, so if there's any questions. Yes.
Concerning the Arquillian run configuration,
Mm-hmm.
when can you take advantage of going away from the local profile to the embedded or managed or remote? Are there any specific considerations when going into a containerized platform?
Well, in terms of using embedded versus remote. So embedded, usually I typically use that one for like lightweight tests. The remote one requires an environment typically that's already been set up. So if you have some type of environment that is hard to configure for historical reasons that you can't easily replicate, as a part of your tests, then you're going to use it as remote. It's a little bit not as repeatable in that case. Some of the containers, like the WebLogic, only support remote or managed, so you can't run the tests embedded. So that would be a driving, if your application, however, is written using Tomcat and you don't have any specific configuration modifications that you made to the container in terms of configuration, you can run everything using embedded. Great, hopefully I didn't put everybody to sleep. I know it's the end of the day. It's a lot of material, thank you.